Hey guys, in this video tutorial, we are going to discuss the cadence algorithm. Cadence algorithm is used to find the maximum subarray sum, and it comes under the category of iterative dynamic programming algorithms. Now, what actually the subarray means? Subarray is a contiguous part or section of an array. We will understand this with an example. So here we have an example in which we are given an array with 5 elements and some subarrays. We can observe here that each subarray element are continuous, which means the elements are one after another. We can have n multiplied by n plus 1 divided by 2 subarrays for a given array, and among those we have to find such an array whose elements when added together evaluates maximum. So here is the pseudocode for cadence algorithm. One more thing, that the implementation we are going to cover here is the most comprehensive, which means it is applicable even if the array contains all the negative elements. Let's discuss the pseudocode. First of all, we are initializing two variables max so far and current max, both with first element of array. And then we are running a for loop, and for every iteration in the first step, we are taking maximum of uh, ith index element and current max plus a of I, and we are storing it into the current max. And in the second step, we are taking max so far, which is our global max, which we are taking with the help of max so far itself and current max. In the nutshell, in the first step, we are checking whether the coming element is contributing to sum or not. We are taking maximum, and which means if it is contributing, then our max so far variable will increase if we take the maximum of max so far at current max. And in the end, we are returning max so far. Let's consider an example. Here we are given an array of 5 elements, and in this array, if we observe, then we can come to know that this 2 and 1 element constitute sum which is equal to 3, and which is the maximum sum in this array. Now how can you find it? So if we apply cadence algorithm here and try to dry run the code, you can get a table like this, in which we have initialized current max and max so far with 1, which is the first element of array. We are running for loop. Now our for loop is here at the element -3. So according to our pseudocode, we are considering maximum between -3 and -3 plus the current max. So -3 plus 1, which is -2, and the maximum element we are getting is -2. And in the second step, we are comparing max so far and current max, which means we are comparing -2 and 1, and we are getting the maximum 1. Similarly, in the next iteration, we are at index 2 and the element is also 2. We are comparing 2 with 0, which is -2 plus 2, and we are getting the maximum element 2. And to find the max so far, we are comparing this 1 and 2, and we are getting 2 as the maximum element. Similarly, for this 1, we are getting current max is equal to 3, which is greater than 2. That's why the max so far value also increases to 3. And in the end, we have -1. So we are comparing -1 with 2, which is 3 minus 1. And we are getting the maximum 2. But this time the current max is decreasing the sum, it is not contributing. So if we compare 3 and 2, we still keep 3 because the global maximum is higher than the current maximum. So we are getting 3 as the answer. The solution has big of n time complexity. So let's move on with the coding part. Initially, we will take an array of sufficiently large size. So we will take array of 100 elements. It will be empty array, and we will take the int n, and we will run a for loop. Here we will take elements in the array. Then as per the pseudocode, we will initialize current max and max so far. Then we will run the for loop again from 1 to n, and here we will say current max is equal to max of a of I, comma current max plus a of I, and in the second step, as we have discussed, we will take max so far is equal to maximum of max so far and current max, and in the end we will print max so far, which is our global maximum. We will take input. So in this array we are going to have the same 5 elements as we have discussed while we were discussing pseudocode: 1, -3, 2, 1, and -1. Our code looks fine. Let's run our code. Nice. Our code has given correct answer, which is 3. So here in this example, if we take all the elements as positive, then we can observe that the maximum sum subarray here will be the complete array. And let's run our code. Yeah, the sum of this complete array is 8. Our code has given correct answer. And if we are having all the negative elements in our code, all the negative, then our code must return such a value which is lesser in magnitude. So our code must return -1. Nice, our code has written -1. So if our implementation of Kadanes algorithm is successful, and in the next video we are going to discuss the binary search algorithm.